The previous stage in the life cycle of a star before becoming a black dwarf is the white dwarf stage, when a star no longer has an internal source of heat and only still shines because of the residual heat from its previous life cycles. The white dwarf gradually cools down to the same temperature as its surroundings by radiating its energy. Over an extended period of time, the white dwarf will cool down so much that it is no longer visible and becomes a black dwarf. However, the life stage of a black dwarf is entirely hypothetical, as there are none thought to be in existence. Since the universe is only around 13.7 billion years old, even the coolest and oldest white dwarfs still have temperatures of about 3000 Kelvin. To become a black dwarf, our star needs a temperature of around 5 Kelvin. Although it is not known, a black dwarf can be expected to float through the universe until it very slowly disintegrates. This process could last trillions of years. When a star reaches the black dwarf age, it will have to be at a temperature of around 5 Kelvin. An estimate of the amount of time that it will take for a star to reach this temperature is subject to many variables, but estimates show that it might take around 15 quadrillion years. Therefore, the relative age of a star at this stage would roughly be around 15 quadrillion and 13 billion years old. Although purely hypothetical, the relative size of a black dwarf would be around the size of the United States, as a white dwarf is roughly the size of Earth. Since a black dwarf has no source of heat, it would theoretically lose all its luminosity and would be invisible. Due to this, and also the fact that none are in existence, there are no genuine photographs of black dwarfs available. The black dwarf stage is the end of a star's life cycle, so there is no stage of life after it, and it will drift throughout the universe, slowly disintegrating until there is nothing left. Thanks for watching.